Please keep in mind we'll have a short Q&A session after the talk, and we have microphones lined up there and there. So if you have a question, please go to the microphone. There is also a survey in the app, so do the speakers a favor and fill out the survey in the official FIRST app after the talk. And if you have any devices on you that somehow make noises, please be so kind and turn them off now. And now for the first talk of the afternoon, here is CRob. He's the Director of Security Communications at Intel Product Assurance and Security, and he's also active in the FIRST PSIRT Services Framework and the lead of the Open Source Security Foundation. And open source is also the big topic of his talk. He has a very cool presentation design. He has a lot of cats. So everyone, please give him a warm welcome, and the stage is yours.
Thank you, Matthias. Hey, everybody. I'm CRob. I do stuff. We'll see a little slide about me in a minute. While we're thinking about this presentation, this topic of open source, I wanted to poll the room a little bit. So who here in the room, raise your hand, if you represent a PSIRT, a product security team? Okay, lower your hands. Who here represents a corporate or computer security team, a CSIRT? Okay, academic, other. So pretty even mix of CSIRTs and PSIRTs. I am here representing the open source ecosystem, the maintainer persona. We'll talk about a couple different personas. Here in this room, PSIRTs would be typically a supplier persona, and CSIRTs, you all get to be probably the consumer persona, because you probably aren't doing the work in upstream, but you definitely benefit through products and services. I've had the great fortune to do open source security for under a decade, pretty close, and I've done a bunch of nonsense you can see up here. While making this presentation, I was trying to find a theme. I was going to hand illustrate each slide, and I said, man, that's a lot of work. And so I had a crappy PowerPoint presentation deck, and then my cat walked in and started yelling at me, demanding to be fed. And that really inspired me, and ultimately made the topic, open source doesn't care about you. In general, the cat doesn't care too much about you unless it needs fed or some of its other needs need attended. But you absolutely should care about it. We're going to talk about kind of understanding your open source problem. We're going to talk about how the open source ecosystem really works and how there's some differences with closed source. Like if you get software from a commercial vendor, that's typically going to be closed source software, and they function a little differently. We're going to talk about the open source threat model, and then we're going to talk about some solutions, because I'm not just going to complain about stuff. I actually am going to help you solve the problem. So, in the room, how many people here know that they use open source at work? I see some hands not raised. You're fooling yourselves. All right. How many people think you know all the open source you use? Right answer. The answer is not everybody knows everything they use. Who here gets an S-bomb from their suppliers? Wicked. 0 people. Alan Friedman is out in the hallway crying right now. So obviously, if you don't have an S-bomb, you can't use it to try together vulnerability information. So I'm not able to solve that problem at this point without having the S-bomb. So let's talk about open source. I worked at Red Hat for a substantial part of my career, and I always thought about the engineering teams as kind of hippie cowboys. They're off on their own, out on the range, doing their own thing. A little strange, but generally they mean well. And when you think about developers, developers have a lot of different motivations. There's a lot of different ways to look and perceive the open source developer. So we'll talk about, there are many different unique goals of open source projects. There is no monolithic the open source. Everybody functions a little differently. Some people get into open source, and this is the key reason most people get into open source, is they need to solve a problem. And they solve that problem through creative software. But also you have people doing academic projects at universities. They'll get their bachelor's, master's, doctorate in software engineering, so they'll have projects in open source. Many people do open source because they want to build and be part of a community. It's amazing the sense of purpose and well-being you get in an active, nurturing community. A lot of people do open source because they want to have fun, or they're teaching themselves some new skills. Some people want recognition from their peers. I wrote the absolute greatest encryption algorithm ever. Look at me, I'm so amazing. Other people feel that because they use open source, they feel that they should contribute back to that open source. Some others just generally agree with the altruistic mission of free and open source software that's created for the public good. But then you have some people that contribute to that because it's going to help their career. I'm going to get a promotion because I have X many projects in GitHub and so many stars and whatnot. And then the very last category of why people contribute to open source is some people get paid by their company to do this work. And that is the reality. There's a lot of different complex motivations. Some people may have one or two of these motivations. Some could have all. But the open source is not very cut and dry, not very black and white. But one thing, if you take nothing else away from this talk, aside from cats are great, is a substantial amount of commercial software today uses and is based off of open source. Depending on the day of the week and the study that you read, between 80 and upwards of 91% of all commercial software has major components that are free and open source. And this XKCD cartoon very humorously illustrates, the fact that there's a lot of stuff in your environment, and then there's this one little project that hasn't been touched since 2003 that you probably don't know about. So, my first controversial statement here, you can read it on the screen, but by using open source software, you are knowingly benefiting from someone else's work and not paying for it. And that's okay. Open source, again, is generally created for the common good or to solve a developer's personal problem. But the developer's personal problem in this altruistic nature does not service your needs. You did not pay for this. There is no contract between you and the developer. In fact, if you read almost all open source licenses, they state as is. So there is no obligation from the developer to do anything to their downstream community. But your business, and that's fine, that's how the ecosystem works, but you need to understand that these upstream goals don't necessarily align with your business objectives. And the fact that they have a release schedule and you have a different release schedule and they're out of sync is not really the upstream maintainer's problem. That's your problem to try to understand and make compensating controls to deal with that. So, what does open source do for you? I have a couple things here to tell you what open source doesn't do for you. First and foremost, open source never gave you a support contract. Upstream maintainers aren't in the business of supporting your business or your software. You may pay a commercial vendor for open source support, and that's cool. There's a contract there. You have some rights and they have some obligations there, but upstream does not have that obligation. Open source doesn't care that you have dependency conflicts, or you have a critical system you can't take down to patch, or you can't update to the next version because of dependency conflicts. That's not there. They are there to create their software and move along, solve their problems, and you are able to benefit from that. Open source doesn't care that you gave your customers a 10-year support contract. Generally, open source is focused on N-1 versions. So they will support the latest version and the version right behind that came out right before it, and that's it. That's your expectation from most open source projects. They don't do this long-term support. There is some other commercial entity that if you need this, they can step in and try to fill that gap for you, or you need to take that responsibility on yourself if you need to support a really long life product. Open source also doesn't care that you can't upgrade to the latest version, because that is almost always the fix in open source. Upgrade to the next version, please. because I'm not paid to support this. I'm going to support the latest thing. So again, it's up to you to figure out how you're going to protect yourself and your customers, your constituents. And finally, open source doesn't know, and open source doesn't care how you cobbled together your solution in your environment, on your equipment, with all this other software. They don't care. They're not there to support that. That is on you, your system integrator, or your vendors that are supporting you. So don't ask open source to help you to troubleshoot your Amazon cloud instance of nonsense, because they don't do that. That's up to you to figure out how to do that. So how open source really works. Typically, a developer has a problem they're trying to solve. So they'll lovingly develop this awesome thing. Then they'll share it with the world. Again, sometimes it's for recognition. Look at me, I did this amazing thing. Or sometimes it's, I want to help a community. Or they're just pushing it out there because they don't want recognition, but they want to generally help the world. Then, that developer, after they've shared this pride and joy with the universe, they kind of wander off and do other stuff. But then other people discover this amazing gift that open source person gave the world. They go, this is great. This solves my problem. Except I need blah, 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 and blah. I need all these additional functions, or these additional features, or I need it to behave differently, or I need the screen to be green, not blue. And the great way how open source should work is, as you find these personal deficiencies with that software, you're supposed to contribute and give back. Hey, you submit a PR, or you open an issue saying, I found this problem, could you change the behavior to do from this to that? Or, better yet, best of all, here's a patch to fix this bug I saw in your software. Could you please integrate that into the main branch? That's how open source is supposed to work. This is how many suppliers treat open source. They see this beautiful project out there on the internet. They don't have to pay anything. They incorporate it into their products, and this is what you get. So I'll let you admire that while I take a sip of water. Many commercial suppliers do not participate in the communities of software that they use, and they all, depending, rarely contribute patches back or any kind of resources back to help that community. And there's a lot of different ways you can engage with communities to support them beyond money. So unfortunately, being that open source is out there and it's beautiful and delightful, it also can become interesting to attackers. All of our source code is fully publicly viewable, which is awesome. So you can take that software, look at it, understand exactly what it does. So can the bad guys, unfortunately. It is typically, most open source communities, those that aren't like single contributors, tend to be globally distributed, where patches are welcome no matter what part of the world is, no matter what your sexual orientation is, what nation you live in. We will take patches from anywhere. And there are generally some rules vetting getting things into the main branch, but open source development is geographically distributed. They are rarely a small group of people in one spot that does this. So that's a nice avenue that attackers could potentially infiltrate that community, because there isn't these tight controls and tight circle of trust between these people, because many of the transactions in open source are done anonymously. There are different economic incentives and feedback loops. So when you're thinking about enterprise software, attackers generally want to get in there because they want to install ransomware, and they want to threaten you, or they want to siphon off corporate secrets. Within open source, the motivations for the attackers can be very different, and also can be a lot broader. Think of things like the SolarWinds attack, where a compromised package was able to help, unfortunately, get integrated into many supply chains, and that the scope of a potential attack, if you're doing kind of a poisoning the well type thing, is potentially broader than just attacking large bank or government office. And it draws different types of threat actors. What is almost universally applicable is that open source projects have a scarcity of resources. They might have limited development environments. They might have limited peer developers. They might not have access to expensive corporate tools, again, because a lot of them don't get directly paid to do that thing. So that brings in some problems. If you're looking at software from a more traditional commercial enterprise, they typically do have very well-managed developer environments. They have things like SDLC, or they have scanning and other protections. Whereas in open source, because it's all out in the public, they don't necessarily have all these. Some of them do. Some organizations, some projects do SDL very well and have very tightly controlled CI/CD infrastructure. Others don't. And unfortunately, and that kind of draws into the very last point, there's a real lack of consistency. You can't look at one open source project and directly compare it to another, because there's a lot of different factors. They could have different skilled developers on each project. They could have different access to testing infrastructure or tooling. And that is the unfortunate reality of open source, is that not everybody's equal. Not everyone has access to all these amazing platforms and amazing tools. So how security vulnerabilities get addressed in different communities, and it really depends on the type of community you're looking at. So if you have, if you're a supplier, you're potentially downloading thousands of open source packages. If you're a consumer, maybe you are a build-it shop. Maybe you're a bank and you write your own online banking platform. So you will actively download and participate in open source. But there's a lot of different types of communities within open source. The first model, and this is unfortunately depending on some language ecosystems, a peer of mine, Josh Bressers, is doing analysis of Maven and NPM and the Go communities. And the overwhelming reality in those communities is that there's a single maintainer. There's one maintainer that does that software, and that's it. And these are millions of packages. And when you have an individual contributor style solution, you're looking at 1 to 2 people. This tends to be a passion project. You're going to have little to no process, because these folks are doing it for fun, or they have a quick fix and they throw it out there to share. There's likely no formal or secure means of sharing security-related information. Normally, they might have an email address. They're not going to have access to a secure Jira or bug tracking system. They're not going to use private GitHub issues. There's definitely no SLAs on the review. It's kind of buyer beware. You downloaded the software. There's probably not going to be a lot of expectation on how you can get support. And they have minimal, if any, documented DevSecOps practices. If you're lucky, you get a man page or a README file that kind of describes things. And that's probably as good as you're going to get in some of these smaller projects. And this is a large percentage of open source software that's used today, and especially in things like Maven and Go and some of the newer, more modern languages. In the middle stands kind of project or community-focused efforts. So this particular piece of software has been able to capture the interest of enough other developers that you have a group of people doing this. You could have half dozen, a dozen, 20 or so folks actively contributing to this project. They will have basic processes, because when you're trying to integrate commits from different developers, you just have to have that process, otherwise you get collisions and everyone's stomping on each other. They probably will have some type of page that lists their contacts, or like what the rules of that community is, how to get a hold of them. And they definitely will have some type of bug review process. So as defects or security vulnerabilities are reported, they'll have a way to triage that. They'll probably have that guy, or Sally, our DevOps gal, she manages the CI system. They'll have typically a handful of people that are focused on some type of formalized DevSecOps practices. And they'll definitely will have documentation, because once you have more than 2 people, you really need to have this documentation. And it helps, so they will share that with their broader ecosystem. You still should expect best effort coordination. And they might have CVD practices with some key either suppliers. Maybe they depend on something upstream, so they've made an arrangement to get pre-notification, for example. Or they may understand that we have these 4 or 5 downstream projects that depend on us, so we'll notify them. But this is not generally formalized or mature in a lot of ways. And then the last type of open source project you can have is like a foundation level project. These are things like kernel Apache Security, Kubernetes, OpenStack, these large, very mature programs. With these types of open source projects, you're going to have a dedicated team of security people that typically oversee that project. There's going to be oftentimes many different related projects. I can't remember, the Kubernetes team told me last week how many projects they had underneath their umbrella, and it was in the hundreds they're kind of managed under this umbrella. So that's very big, requires a lot of coordination, high maturity style project there. So with that, you're going to have well-developed documentation and process. You're going to have well-communicated and well-documented communication channels. This is our security policy. This is how we want to intake issues. These are SLAs people can expect for a response, and generally kind of what our patching methodology is. These larger communities will have all this documented. You'll have dedicated people performing compose, build, deployment, and security functions within that project. They're going to have documented release timelines, and they very typically will have a well thought out CVD process and will be well integrated with other communities they depend on or supply. So again, there is no the open source. You'll see any mixture of this, and no one kind of puts a sign up saying, we're foundation level or we're an IC style project. Generically, I have a laser. Pew. Oh, it's a green laser too, nice. Generically, open source projects will follow a very simple ingestion, triage, and disposition process. Somehow, some way a security flaw is discovered, somebody reports it, they're going to evaluate it, they're going to do something, and it's generally fix or won't fix. If they fix it, great, the patch is thrown out in the world and the developer moves on with their life. This whole second half of the screen, second 2/3, this is your downstream suppliers and what they have to do to support that change upstream. And the worst situation is when you get into a won't fix scenario with upstream and your commercial supplier has some type of long life support plan in place for you. So that becomes an interesting little exercise in negotiation. Upstream, not upstream. So kind of comparing the two, when you're looking at closed versus open source. Typically, closed source is supported by some corporate entity or entities, and updates will typically only come for that one supplier. Versus open source, where it's supported by the community. Update could come from anywhere. Anyone that has the interest and ability to push a patch potentially can help contribute to fix a solution. For closed source, they're typically governed by stakeholders, regulations, and they have customer demands. So they're going to be reactive to customers. So if you are supplied open source software by a commercial software vendor, you have ability to influence their roadmap, influence how and when and why they fix things. Versus open source, there generally is little or no governance, and the open source does not have regulatory oversight. They are not beholden to PCI, GDPR, yes, but generally the typical regulation things are not compelling to open source because, again, they're not a commercial entity. And generally, as I mentioned up here, with number one, a lot of times when you're dealing with people in open source, you don't even get their real names. We use hacker handles or pseudonyms, very typical in this community. So if you are an organization that some nations like to state we only like software created in X or Y region from people from A or B country, you don't have that luxury within open source just because of the open global nature of it. Looking at closed source, they generally have a process around security reports, and communication is not always done in public. Oftentimes with commercial software, you'll see embargoes where there'll be some type of period where that supplier needs to get all their ducks in a row and release an update. Versus, for better or worse open source, almost always the defect tracking process is open. It's a very mature, very large project that has a private disclosure process, and almost to a fault, all open source developers are, when the fix is ready, it goes out the door. I'm pushing it immediately because they're focused on their downstream in this way. They want to get that fix out to their consumers. Whereas commercial entities have a lot of other constraints on them, like shareholder value, and they can't necessarily stop everything to release a patch this afternoon. When you're looking at closed source, generally those releases are tied back to some predetermined release schedule. You have a quarterly release cadence, you have Patch Tuesday. Whereas open source is, again, screw it, when it's done, it's going out the door. Great, good luck. We hope you all are happy with the software. And then 5, typically with a commercial vendor, they'll try to orchestrate updates, especially if there's any kind of interdependencies between vendors. And looking at the open source counterparts, there typically isn't a lot of that understanding of who ingests them and who we need to notify. So it's going to be much less coordinated. 10 minutes, no way. Oh, man. All right, here's a non-exhaustive list of threats that could happen within an open source ecosystem. Very exciting. Because on the internet, no one knows you're a cat. I'll tell you the story behind that in the future. So when you're thinking about how a lot of commercial suppliers support open source, it's not really great. They don't really do a ton of effort to help improve that maintainer's ability to execute and deliver software more quickly. So how can suppliers work better with open source? First and foremost, it should be the obligation of every commercial supplier to understand every piece of software that is delivered in an offering they supply to someone that pays money for it. That should be the first thing that any well-intended company should do, is understanding what I'm ingesting, where I got it from, what the rules of that community are if I need to request a change. You also need to understand how issues are worked upstream. Some communities we only have a public defect tracker. So if a researcher submits a security vulnerability, the world can see it, which as a defender, the clock starts ticking right there. Others are more amenable, more mature, more understanding of their downstream ecosystem, so they will have practices that allow them to take some issues in privately, kind of triage it beforehand before working on a release. Suppliers need to understand how patches are released by that project. Is it pushed out on GitHub? Is it out on some random AWS file system? They need to understand how that community works, where they're putting their software, and how they can get notified of it. A lot of times advisories are not something that upstream communities do, so the downstream consumers, like suppliers, need to understand how they get notified and how they need to notify their consumers. So let's talk really quickly about this thing. Who here has heard of Log4j? So my perspective, the upstream Apache team, the security team, while not perfect, did an admirable job. They handled this vulnerability to the best of their ability under the constraints they were given, and they actually executed pretty well. So on December 10th, there was a CVE released. Very bad, CVSS 10, ooh, scary. So the team within, the embargo broke, and they actually the information got leaked by a vendor that scraped GitHub commits. So somebody started tweeting there's going to be a big Apache event. So 6 hours from that embargo leak, the Apache community had the bulletin out, had patches ready, and had notified their main downstreams. Unfortunately, the first fix wasn't complete, which is can be common, especially when you're working under pressure, and the fact that things went about 3 or 4 days early. That it was an incomplete fix. So just 4 days later, the Apache team released a second fix that closed up that little hole that wasn't addressed. And you'll note that what wasn't addressed was non-default configurations. So someone altered the behavior of the software the developer intended to make it work a different way. But they generously released a fix for that. Then, a couple days later, there was another issue. So while they were investigating or remediating this, they found more issues as part of this response. And they actually, at the end of the day, for this particular problem, there were the main issue, the incomplete fix, and then 2 secondary CVEs that were discovered. So to think about this, the reason that they leaked and they went early is because they had evidence of active exploit in the wild. So they did, for the best interest of their community, released early. And unfortunately, it was confusing. Not everybody got the message in time, but they were still able to get everything out within 6 hours, which I don't know many organizations have that ability to spit a patch out that quickly. The security team published it within hours. Yay! First patch wasn't sufficient. Boo. Orgs working on testing and rolling out the initial integration and testing of the patches had some rework to do. That's an unavoidable after effect. If you are working with open source software, again, the goal is to move quickly as they can. So they move quickly, and sometimes it requires some rework downstream. And then what was really fun is some vendors were supplying Log4j version 1, which was publicly deprecated 5 years ago. And then they sent demand letters to the Log4j maintainers demanding them what are they going to do to fix this software that they had publicly said 5 years ago we're not doing anything with anymore. Not cool. Hopefully, if you got nothing else from Log4j, I'm going to do questions here in a minute. If you take nothing else from this, you need to ask questions of your vendors. You need to understand what software they're supplying you and some of the practices of how things are done. So my slides should be available after the fact. I'll make sure that they post it up there, but I have some suggestions. And first and foremost, the best way you can fix this problem is by contributing to software that you use. And contributing could be having engineers participate in the project, fix a bug or two, offer to help do documentation, help them with advisories, donate tooling so that they can do this testing that downstream consumers want. All right, and there is somebody doing something about this. So the other group I work a lot with is the Open Source Security Software Foundation. Say that fast 5 times. In response to the executive order released by the Biden administration last fall, the Open Source Secure Software Foundation has released a 10-point plan, a mobilization plan, on how the foundation, a group of volunteers, will be working on fixing some of these problems, like education, risk assessment, digital signatures of software, getting software rewritten into memory-safe languages, working on sharing data, doing code audits, better scanning tools. I get to create an open source CERT. Yay, me. And then, SBOMs and improved supply chain security. So the industry is working on this, and we need your help. If you are interested in any of these topics, don't hesitate to reach out to the foundation, show up to a working group meeting. It's fully publicly available. Everyone's welcome. And then as we're developing solutions like academic scholarships and SBOMs and PSIRT, you will be able to participate and help shape those solutions. So by engaging open source the right way, it can be pretty cool. So I think we have like 3 minutes for questions. So what questions might have I inspired the group to have? Did you learn a little?
So if you have any questions, please line up at the microphones. And at first, give Chris a warm applause for his awesome talk.
Thank you.
Hello, I'm Doug. I'm not a programmer, so might be a stupid question. Is there any system by which one entity can, in a way, sign or approve a piece of code published by B entity? So that I can look at the code and I can see, oh, entity A, which I trust, has approved that code.
So there is a project that the foundation supports called SigStore that is all around digital identity of developers and code signing. And so you can get that pedigree and provenance. And it's all kind of a blockchain style repository so that once that software is signed, you can always check the hash with the main repository to be able to validate that. So yes, there are tools that are coming and that are, actually they just announced that Kubernetes is moving over to using SigStore. So that, yes, there are ways you can do that.
Thanks.
You're welcome.
Is there a listing of open source projects in danger, so to say, that are, for example, under-supported or where there would be a need for, which are widely used and where there would be actually a need for more support on that? And what is your opinions on the best ways of providing financial support into the general open source security ecosystem? Is it through that foundation, or are there other projects on this area?
So to your first question, there is no list of known at-risk projects, but there is the converse. We partnered, the Linux Foundation partnered with Harvard University, and they did the Harvard Census 2. So they ranked the top 117 most used, most critical projects. And that's what OpenSSF is focusing in on, to try to go in and do one-on-one developer code audits with these people, trying to get them access to tools and whatnot. So there isn't like an at-risk list, but there is a list of, we know that these pieces of software are used a lot, and we're going to focus in on it. And then we're also focused on the next 10,000 projects, where we have a project called Alpha that's directly engaging the top 115. And then Omega is trying to address the 10,000 below with what we learn on how to engage those projects, kind of filtering those practices back to the larger ecosystem. And OpenSSF is one foundation that you potentially could partner with. And again, contributing doesn't necessarily need to be money. But it could be. That helps us get contractors, or helps us buy tools, or get moving infrastructure from, I worked with a guy that had a array of Raspberry Pis underneath his desk in the Netherlands. We were able to help get him funding to be able to convert that into an AWS Kubernetes cluster. So there are a lot of different ways. So OpenSSF is one foundation, but there's a lot of great foundations, the CNCF, the Confidential Compute Consortium, a lot of different ways. But if you have specific questions, don't hesitate to come ask me afterwards.
Good. We have time for one more question.
Did you like the cats? All right. Well, thank you. I appreciate it.